For this video, we're going to be taking a look at how we can put together all these components to control a motor. So the first thing we're going to start off by taking a look at is this thing right here. So this is called a MOSFET transistor, and what this does is it acts like a gate, and it allows current to flow in and out depending on whether that gate is open or closed. And this kind of switch, we could call it, is very special because it allows us to change very rapidly between on and off. Now, by contrast, we also have this thing right here. So this is also a switch, but this is what we call an electromechanical switch. So these giant blocks right here, inside of each one of these, there's an electromagnet. And when you put some current through it, the electromagnet closes the circuit and it allows current to flow through. Now, the difference between these two is that in this MOSFET transistor, there aren't any moving parts, whereas in this one there is. And what that means for us is that we can turn the gates on and off very, very quickly compared to this one. So we can use something called PWM, and PWM stands for pulse width modulation. And what that means is we can change the power given to something like a motor by turning on and off the gates very quickly. And you can think of it as this motor will go at a certain speed depending on the amount of times of on signals that we send versus off signals. If we send a lot of on signals, then this motor is going to be closer to running at full speed. If we don't send a lot of on signals, then this motor is going to slow down. So you could think of it as the ratio between the number of on signals that we send versus off signals. The next thing we have here is a terminal bus. And what this is just a very simple device where you have these screws that are all connected, these pairs of screws that are connected to one another by a plate underneath. And we can connect each of these pairs like this with these wires. And what that allows us to do is we can distribute power to multiple devices, right? So if you imagine we had this side, we had a power source on this side, and this side was negative and this side was positive. Well, here we've connected the electrical signal coming from here to this one, and the one from here to this one. So what we can do is we could connect one here, one cable on this screw right here, and current will flow from this red cable to this red cable. But if we had another cable here, then current from here, because it's shared here as well, the current from here would also flow through this one. And if we had another cable over here, then the current from here would also flow through this one. And in this case, we don't really need this setup because we are only powering on one motor. But suppose we wanted to expand our setup and we wanted to include multiple motors like this one, then this would allow us to do that because we would just need to connect one more cable here for the positive and one more cable here for the negative, and we would be able to distribute power like that. One thing that I didn't mention is that this motor right here has some tape on it, and if we remember originally, the goal was to have an electromagnet and be able to control some ferrofluid using an electromagnet. But instead of going right away to the setup, it's a better idea to start with a few prototypes and then build on from there. So I've decided to instead use this little motor right here and put some tape on it so that way we could see how fast it's spinning. And the next thing that we see here are these alligator clips and jumper wires, and we're going to use these right here to connect our different devices together. There's also these kinds of cables, and we use these typically in our breadboard right here instead of these. You could also use them, but I find that these work a little bit better when connecting parts of the breadboard together. What we also have is a 1 kilo ohm resistor that we'll use to regulate our transistor. And lastly, we also have a power supply cable. So this is what's going to be giving power to our whole setup. And what I've done here is I've cut the wire, I've cut the power supply wire, and I've soldered together each end of the wire with a male to female cable. If you don't know how to solder, the alternative to that is you can use some alligator clips and just connect the ends of these to alligator clips. But it is, I would say, a better idea to solder them together just because we have, this is our source of power that's flowing through. So the last thing we have here is our Arduino. And the Arduino is a very small computer that we can program and send signals to. And we lastly also have this cable right here, USB cable, to send data from our computer to the Arduino, so that way we could program it. So these are the materials that we'll be using for the tutorial. And in the next step, we're going to put all of these together. This is the wiring diagram. The link for this page is on the description. On the same page, you can also find extensive documentation on the entire project. And also on this page, you will find common errors that I found while doing the project, as well as solutions to each of the errors. So the first thing I've done is place the transistor on row G on the second pin. Next, we're going to take our resistor and put it directly above the transistor. Make sure that the gold ring is on the right side. Now we're going to take one of our wires and plug it into the row J, the rightmost pin. This wire is going to be connected as ground to our Arduino. And we could, of course, directly connect it to our Arduino, but we are thinking in terms of, well, what if we had multiple motors that we wanted to control? So by placing them to the ground line, to a shared ground line, then it allows us to expand easier. We're going to also take one more wire and connect it on row J, the very middle pin. We're going to take a jumper wire and connect it on the topmost left pin under the transistor. And this is going to be our PWM connection to pin number 9. So now we're going to take our terminal bus we're going to take the negative end, the ground end, and connect it on the rightmost pin under the transistor. Now we're going to take our positive side and we are going to connect this to a red alligator clip. And now we're going to connect this red alligator clip to one of the ends of our motor. Black alligator clip. And we're going to connect this to the other end of our motor. We're going to take the other end of the clip and connect it to our orange wire. Now we're going to take the ends of our terminal bus and we are going to connect these to our power supply ends. And I made a small mistake earlier on today where I had male to male cable instead of a female to male cable. So what I'm going to do is just connect these two together using an alligator clip. And that's it. So now we're going to head over to our computer and program the Arduino.